Hello, people. This is Anuj from Invictus Robotics. I welcome you all. Sorry for the inconsistency. We have not posted anything for the last 2 months, but we were doing something. Actually, this should not be the reason, but yes, this is the truth. Okay. Today we are going to cover the introduction of CAD modeling, and we will be looking for the different CAD softwares, Fusion, SolidWorks, CATIA, and FreeCAD. Yes, I do have this four in my system. So for the initial phase, we will be using Fusion, but we will switch to some other CAD software after that. Okay. So before going further, please check our channel, Invictus Robotics. We have covered uh, multiple videos on electronics and how the softwares are working and basic electronics. So please go and check it out. So let's go. Yes, the CAD stands for computer aided designs. If you're watching this video, I'm sure you know what is meant by computer, right? But the one of the most probably misunderstood term is aided. What is meant by aided? So basically, aided means assisted, right? Assisted. That means the uh, it assists the designer. The computer assists the designer in creating and managing the design. Okay, that is meant by it. And putting this all three terms together, it means using computer technology to assist human in creating, modeling, drafting, or design. Okay, uh, the CAD software is not only used by uh, mechanical engineers or the other, it also used by the product designers. It used by the civil engineers and many more, right? Okay, and CAD doesn't mean only creating the 3D model. It does not define it completely. There is a complete definition, but we will look for further. And today we will be looking for the. It is going to be an introduction video. So we will be looking the at how the CAD software works behind the screen, and we will look basically interface of the different softwares. As I mentioned, I have the four softwares, and we will look uh, the interface just for today. And today we will majorly focusing on the how the CAD softwares are exactly working behind the screen. Okay, that is how we are going to go for, right? So a CAD modeling does not store up 3D models like a picture. It stores a mathematical description of a geometry. Are you getting me? It does not stores pictures as stores a picture. It doesn't stores 3D models. It stores the mathematical geometry of the whatever we are designing as a sketch or as a model, right? So how does it works? Okay, let's see. As I mentioned, uh, it stores the description of the geometry and how does it works. The question is how what actually happens. Let's take an example of line. So the question is, what exactly happens when I create this lines? Okay, so when I create this line in the geometry, uh, in the uh, uh, behind the screen, it is storing the coordinates. Okay, it's not storing the pixels or the anything. It is storing coordinates. The coordinates might be x comma y comma 0. Let's take it for now. Okay, and here let's take here as the uh, this is your a coordinate and this is your b coordinate. And similarly, and here it stores. Let's take a comma b comma 0. Okay, so this is how it stores the coordinates. So in short, what I want to say is the it is happening on the coordinate system. It is storing the lines on the coordinate system. If you see the line I have drawn, it's a two-dimensional line, so it is storing uh, it is it is stored in two dimension, that is your x axis and your y axis. Okay, x axis and the y-axis. Got it. And similarly, if you add one more axis, that is your z-axis, the 2D model converts into your 3D model. Okay, the has. So in CAD is basically a geometry plus mathematics. Uh, it stores points, lines, circle, arcs, uh, then solids, curves, surfaces, etc. And this is how everything joins together and makes your model. Okay. So got my point. In short, the what I wanted to say is CAD is basically mathematics. Okay, got my point. And when you let's take one more example. When you try to draw a circle, what happens behind the scenes? So when you try to draw a circle, sorry for it. Okay, when you try to draw a circle, it does not create infinite points on it or uh, billions of small lines on it. It stores the mathematic function of it. That is x minus a whole square plus y minus b whole square equals to a r square. Okay. So when it stores this, so because of storing this instead of any pixel or the lines or the points, the indefinite when you zoom indefinitely, it shows you the proper circle or the arc of it or the line of it. Okay, because of the it it is storing some r radius, right? So that is how it works. Got my point? Now, yes. Got in short, this is a coordinate system working behind the scene, right? Now, this is how we talked about 2D sketches, lines, circles, and the other shapes and all those stuff. Similarly, this is the square stores, the rectangle stores, and the things, right? Okay. Now, the other question is how 2D sketches turns into 3D models. Okay, so there are some few features that are pad. In CATIA we used to call this pad, and in Fusion and in SolidWorks we used to call it as extrude. Okay, so when you draw a square and suppose this is your uh, suppose this is your 25 mm by 25 mm. Okay, now this is your square in draw 2D geometry. Now you want to make it in a turn it into a cube, and you use the command called as extrude. Okay. Now when you used extrude command, what it happens is extrude. Yes. Now when you use extrude command, what it happens is the first thing when before extrude command, it was working in x and y coordinate. And when you applied extrude command, it start moving in z coordinate. So your square start growing in your z coordinate, and it turns into a cube. Okay, that's all. It's layering on it. Okay, and this is a 25 by 25, and if you have given the extrude command extrude of 25 centimeter. Okay, so in short, uh, in short, you you define geometry. Sorry, let's let's take this. In short, you define geometry. Okay, and then behind the scene, it applies mathematical operations and creates a solid. Okay, this is the your workflow. Oh, sorry. Uh, yeah, this is your workflow. Got my word. So what we covered, the first thing is about what CAD means, then how the sketches or the things store in this is how the sketch and thing stores in the coordinate system. Then we looked what happens when you give the commands like line or the circle or the square. Okay, this is how it stores in the equation format. And then how the 2d 2d sketch, mm, how the 2d sketch converts into 3D geometry. Okay, and this is like the final summary of it. Okay, now, but how does CAD know that something is actually a solid? Okay, so here it comes the concept of computer graphics. The question is, how does CAD know that something is actually a solid? Okay, okay. So, modern mechanical CAD systems generally uses a mathematical uh, uh, mathematical representation called as BREP. BREP. That stands for boundary representation. Okay. So the boundary representation is your concept in computer graphic which defines their outer limit. Okay, so what should be the limit of it? Let's not get into that. But for now, let's take it as it defines your outer limit of the geometry, right? And how does it defines it? Okay, let's take an example of a cube. Okay, so A very bad cube. I think I'm missing something. Let's redraw. Let's not draw this bad cube. Okay, I can draw better. Uh, let's draw it. Uh, okay, let's take a cube. So now what is happening? You have vertices. Okay, you have vertices. There are 8 vertices. Okay, now in the coordinate system, you define this all vertices. Okay, whatever. Okay, kind of wherever those 8 vertices. Let's take it further now as a uh, 4 vertices, right? And then there are this edges. Okay, this all 12 edges. Okay, now you have put the vertices and then this vertices joins and turns it into edges. Okay, and, and now when multiple edges join, it converts into a face, right? So vertices, when vertices meet, it turns into edges, and when edges meet, it turns into a face, right? Now, when multiple faces meet, okay, fine. When multiple faces meet, it's turned into a solid. Okay. Actually, I have made some notes and I'm doing by. Okay. So this the connections of all this is known as BREF, that is boundary representations. Okay, and this is a concept of computer graphics. Okay, right. Now there is an one more important concept about geometry and topology. Okay, now what is geometry? Okay, the geometry defines the thing you sketch, the things like the square, the triangle, or the circle, etc. These are the complete your points, your lines, and uh, this all considered as the geometry. Now, the topology means how this all geometry going to join together. Okay. Now we have talked about the uh, cube, like multiple faces, the squares joined together and creates a closed cube or closed shape, and it creates as a solid cube, right? So uh, it defines the connections between all these geometries. Like the sketch is basically stores equations. Okay, the sketch is basically stores the equations, right? Now In the same thing, there is the concept that uh, if you have observed, your shape might look your models sometimes look like it is made up of complete triangles. So basically, it stores in the form of triangles, and kind of we will get it more on after that. So in the upcoming videos, we will see why CAD models looks like triangle. Okay, and yeah, sure. It okay. So this is how it sees. Okay, now this we all talked about mathematics. Now the question arises, uh, does it means the model is physically correct? Like what I mean by physically correct, the question is, does the model is physically correct? What I mean by that, does it uh, actually following all the physics rules? The answer is absolutely not. Okay. So when you create and a shaft of 25 mm OD, so it doesn't mean that it will take the actual loads of it, or it will follow uh, the how it is going to react with the heat, other environments, the what amount of stress can it handle, and what physical properties it does. And to do this stuff, then uh, the FES softwares come in these pictures, right? So we for the physics simulation of the for the physics applications of the CAD software, there are FEA softwares. Okay, finite element analysis. So in nowadays in many of the CAD software, it is a basic inbuilt, but for the dedicated FE analysis, there are softwares like ANSYS, MATLAB, etc. Okay, now let's take a broad summary of it. So yeah, we have uh, we have CAD software. Okay, then we create CAD builds from mathematical uh, definition. That's too bad. Okay, mathematical definition. Then what is mean by mathematical? How does mathematical definition work? With the help of geometry, constraints, parameters. Okay, and this all get compiled with geometry solve. And then there should be a thing, there should be a thing which shows the relationship between all this geometry constraints and parameter. Then the topology comes into the picture. That is your boundary representation. Mm, yeah, that is your boundary representation. Right. And getting together this, we will we are able to create 3D models, 3D CAD models. Okay, and just not with this on this with this, the same things, almost the same concepts happens in, as we see in the CAD is obviously, and in the CE as well, and in the CAD. Okay, CAD modeling is not a picture of an object. Okay, so the moral of the story is the CAD modeling is not a picture of an object. It is a mathematical definition of or the description of an object, the geometry and the how geometry is connected together, and it is creating. Okay, that's how it works. Now, let's see some. Uh, let's see the actual CAD software. So let me share you something. So this is Fusion. Again, hold on. So this is Fusion. So Fusion 360. Fusion 360. I have not found anywhere the crack version of Fusion because according to me and according to Google, the Fusion has no its crack. The crack of Fusion does not exist. Maybe I may be wrong because it works on completely on the cloud and it fetch the real time uh, information of the thing. Okay, so let's take a small example. This is the Fusion, and here the let's take out the interface, the home. The first thing is home of it. Here you will be able to create new designs, new parts, and the geometry, and you will be able to see your past, whatever designs you have done or the thing, right? And here you can invite your members working with and work together. Okay, and this is your data panel. Mm, where it opened. Okay, let's see. Let's click on new design. So when you click on new design, there are few pop-ups you will get. Part part design, assembly design, hybrid design, drawing, electronic drawing, and electronic libraries. Let's for now, let's don't focus on electronic designs and electronic libraries. Let's focus on these four parts. In the part design, you will be able to only draw particular part and you will not able to connect multiple parts. Okay, and in the assembly you joins multiple parts and makes a complete body, and you also defines how it is going to uh, behave, like a rotation or the solid constraint or the sliding motion, etc. And in the hybrid design, it provides both part designs and the assembly. I mostly prefer hybrid designs because it provides a better reference and all. Okay, and the drawing is to understand how the model is and how to manufacture the model, and it provides you the 2D sketch of your models of about all the things, right? Let's click on hybrid, create new, and this is how your interface looks like. Here, the first thing, you will be having an option of design, generative design. In generative design, you need to uh, define endpoints, and it will generate a most suitable structure possible. And in rendering, animation, simulation, as I mentioned before, many CAD software is also providing some uh, small end simulations like the stress heat or the stress strain part. And manufacturing, it comes for CAM, how the uh, CNC machine is going to work, what are the processes required to build the entire part and all those stuff. And in the drawing, you make your 2D designs and all those stuff. And electronics is electronics. And here it comes like create, modify, assembly, configuration, and cut. For now, this video is so making is going too long. Uh, let's explore other interfaces and uh, so other CAD softwares in the next videos. And yes, thank you for it. See you soon.